All right. How long is that warning out there for? All right. So, Bree's question is, a minor sector and a sector look a lot alike, right? Or a minor arc and a minor sector look a lot alike. How do we know the difference? So, an arc is this guy out here. An arc is in one dimension. So the arc is just a line on the circumference. The sector is the area that we have shaded green. It's in two dimensions. Is dimensions dim or DE? I'm so bad at spelling. D-I-M or D-E-M? Say it again?
I think it's D-I-M.
It is D-I-M?
Yeah,
Okay. It's on video. Everyone's saying I'm right, correct? Thumbs up. Don't change it? Okay. So if every comment on YouTube is you can't spell, I openly admit it, but I have backup now. So Bree, the difference between a minor arc and a sector is, a minor arc is just the smaller part of the circle, right? This is n over 360. This is, well, let's call this n1 over 360. That just means the first n that I'm looking at, right?
This is 3, this is 90.
Say it again?
This kind of looks like, I feel like this is still 90 or 360.
It probably is if we measure it. This part in purple is n2 over 360. Since n2 over 360 is greater than n1 over 360, that makes this the minor arc because it's less than 180, and this is the major arc. Now, what we could do is this would be the minor sector, and then everything else here is the major sector. That's a G, not an E. See, I told you I'm bad at spelling. So I guess the best way to think about it is when we're talking about minor and major parts of a circle, it's just, is the angle that made them greater than or less than 180? The sector, though, is talking about how much color goes inside. I guess Becca's next, and then she. You had a question?
It was just to let you know.
Thank you. Same for you.
You wrote something down about like the diameter. It was like in the inscribed thing.
Oh, yeah, yeah. That was just, I'm going to put that here. For the inscribed angle, what I was saying is, if I know for a central angle, N and N go together, and then here, let's call this X, then I'm going to have 2X out here. The way I remember it helps me also remember diameter and radius. From here to here, this is 1 radius, right? So it's just going to be N times 1 for the central angle. But I need a second radius to get all the way to here, and that's how I know it's 2 radii times X, or double it to get there. It's just a way to remember, because if I've been working here for 4 years. If you put me at the Chevy dealership, spun me around with my eyes closed, I wouldn't find my way back to the school. So I like to associate things as much as I can. Any questions on this before we try a few practice problems?
I'm ready.
You ready, Ruru?
Yeah.
All right. We got 1 vote of confidence.
Maybe not.
don't inflate it right away. I'm using you to pump everyone else up when they were starting to fill it, and then you put it away. All right. Since Rune's not feeling confident, I'm going to ask him to answer
I'm
this.
just kidding. Alright.
No, I know you were. That's why. If I didn't think you were feeling confident, I wouldn't say. That's what you. Let's say this is 75 degrees here. What is the value of n? If the arc is 75, what is my central angle?
Oh, wait. That's 150, right?
Say it again.
75 times 60 is like
Vernon, is it all the way down here, or is it a central angle?
So 75.
It is, yep, central angle and arc measure are always the same. We'll do.
Oh,
Devin, if my central angle is 42.5, what's my arc measure? 42.5, yep. So whatever you see here, this is the central angle, it's gonna be the same arc measure. We'll do one more and then we'll move on. And I'm gonna pick on Bree, just because I said Bree, let Shani go first and Bree talk anyway. Bree, if this is y squared, what is my arc measure? Yeah, it's y squared. It doesn't matter what it is.
So it's basically like the reflective property or some or community.
Are you thinking of the reflexive property from flipping?
Yeah.
You think of that or the transitive effect, they just go together.
I got you.
Anything that this measures, if it's a central angle, then the arc measure in degrees is exactly the same. You can copy it straight down. Now, I know you have a whole sheet of paper there for that. Any questions about central angle or can we move on? I feel like most of you guys feel like we covered it enough.
Wait, this is central angle?
This is central, yes, sir. Okay, I scared me. I thought I printed it out of order somehow. All right, now, the only difference here on your next sheet is now we're talking about radians. If this is 2 pi thirds for the central angle measure, remember when we talk about radians, we're going to stick to theta.
Theta?
Yep. Let's call this AB. And I'm only going a little bit more in detail because, oh, this would have to be theta then, just to keep it simple. What is the measure of arc AB? I think I called him Devin last. Devin, do you want to pick somebody? You could point this one time. Wait, Devin, the one thing I said is don't point and say you. But it's Raneem, go ahead. What is the measure of our AB, Raneem, if the central angle is 2/3 pi?
Wait, wouldn't it just be double? Or is that double?
That's the one yeah, so there's one radius between here and here, so you just copy it up here. Don't let radians change any of the rules.
So it's the
Same
same
thing.
thing. Radians are the same thing.
In central angle terms, yes. And you can convert this into degrees easily, but not today. This would be, yeah, Abby.
So radians is what it has called.
That's the best way to think about it now. When you see me in pre-calc, we'll make a better definition. But yeah, anytime your stuff's represented in pi, in terms of something pi, it'll be x pi y, where x can be, here x would be 2, here y would be 3. This is your standard format for radians. And now,
What number is that?
this is a y. So it's just two variables that you can see they can check in. Now, right now, I just want to say before we go to the next slide, all we're talking about is the measurement, not the length. This is just if this opens up this much, then it has the same measurement. We're not talking about length yet. Length is where we go back to n over 360 times the whole circle's circumference. Can we move on to the next one, or do we have questions? Oh,
If you gave me numbers and asked me the radians, I wouldn't know how to answer it.
that's good because you can't, and that's why I was saying, make sure we know that that's not good. Yeah. If they said, what's the radius here? You can't do that. All this is telling me is, if my hand's opened up this much, then that is the angle of the arc too. We'll find the radius next. This is just a generic circle with no size, just the measure. Yeah.
What's the difference between the measurement and the length?
Say it one more time.
What's the difference between the measurement and the length?
That's a really good question, and it boils down to, so the question was, what's the difference between the measurement and the length? Here, let me grab this for sure. For the measurement, I'm going to use a protractor, and all this is telling me is how much did the angle open up. And if I measure this at any point, I should get the same measurement every time. So the measurement is just when it says like central angle measurement, it's just saying how much or how many degrees if I start here and go to here did I have to move. It's not saying anything about how far did you travel, it's just saying how far on the protractor would I move. And then when we introduce length, we're going to use the straight edge to measure that. So right now we're just saying how many degrees apart is it to go from here to here, here to here, or even here to here. And what the central angle is telling us is it takes the same number of degrees to travel along there, but we have nothing to do with length yet until we define it. And that's why your question was good, because you can't do anything. All we're talking about is how much are we measuring, not how much are we moving. Abby.
If you're gonna inscribe angle in radians, how do you find the arc length by multiplying it? If it's like
Same thing. So, great question. Abby said, let's do this one. Abby's question was, we have an inscribed angle, and this right here, we'll call it theta, is still 2 pi thirds, right? And you're asking what's the arc measure? Well, to go from here to here, it's 2 theta, right? So then we're just going to do 2 times theta, which would be 2 times.
Oh, so you can multiply it with just the other side.
Exactly.
So you can only multiply with like times 2 if it's inscribed.
Only if it's inscribed, yes. Abby, does that work? Make sense?
You just multiply the top number.
Yep, so this is 2 times 2 pi thirds, and if you want to think about it this way, isn't 2 just 2 over 1? And then we go straight across. So 1 times 3 is 3. 2 times 2 pi is 4 pi. So I guess ideally we go back to August of 2020 and we figure out how we can make you guys just my first walk of the day. We have a break here. These are, you guys are reaching way beyond this class, but it's still good to kind of see it. Can't write hopefully on your notes. All right, any other questions before we move to the next one? We're going to go from just measuring the angle, that's all we've been talking about, to actually finding the length we would have to travel now. Now, Abby, I'm going to head you off on this one. If you're asking for the arc length in radians from an inscribed circle, we're not ready for that, okay? Just because I see how you're thinking. Everything we're going to talk about here is only working with a central angle, okay? There's way more stuff to go from inscribed. So,